Let's talk about what's called right triangle trigonometry. So first of all, just a little bit of terminology. When we say right triangle, let's try that again. When we say right triangle, what we mean is an angle where one of the angles is 90 degrees, okay? And the other angles are what we call acute. And an acute angle is an angle, let's call it theta, that's a Greek letter theta, that's less than 90 degrees, but positive, that is greater than 0 degrees, okay? That's what we mean by acute. So here I have an example of a right triangle, and we denote the 90-degree angle with like a little box like this. Now what we're going to do, and you can see the acute angles, right? This is one of the acute angles between 0 and 90, and this is the other one. So what we're going to do is we are going to define trigonometric quantities for the acute angles. So let's say that we were talking about this angle, for example, right here. Let me denote this angle as theta. Okay? Now, in reference to theta, we give the sides a name. And the side opposite the angle, so I drew theta right here, right? The side opposite this angle would be this side, okay? And we call that the opposite side. And the side that's right next to the angle, now you might say, well, which one? This, the side of the triangle opposite the, across, if you will, from the 90-degree angle, that has a special name. That's always called the hypotenuse of the triangle. Hypotenuse. And the side of the triangle that's not the hypotenuse, but that's next to the angle, we call that the adjacent side. So this is the adjacent side right here. So the way it goes is the hypotenuse is always across from the 90-degree angle, and the opposite is always across from the angle, and adjacent is the leg next to the angle. Okay? Now you have to be really careful, because if the angle, if you're talking about this angle over here, you know, well, that's still the hypotenuse, that doesn't change. But this would then be the adjacent side, and that would be the opposite side. So these words adjacent and opposite, they refer to whatever angle you're talking about. Okay, so with this terminology, we define 6 trig functions of this angle. The first one is called sine. So when we say sine of the angle, and it looks like sin, there's no e on it, we just write, this means sine of the angle, okay? That is defined to be the ratio of opposite divided by hypotenuse. So we write opposite over hypotenuse. And OPP is opposite, and HYP stands for hypotenuse. And the reason we don't just write O is because we don't want to confuse that with a 0. Okay, so that's the definition of sine of an angle in right triangle trigonometry. And then cosine of the angle, COS of the angle, that's the adjacent divided by the hypotenuse. And the tangent of the angle is defined to be the opposite divided by the adjacent. And let's see, what else is there? There's the cosecant of the angle, which is the reciprocal of sine, so it's the hypotenuse. Whoops. Let's try that again. It's the hypotenuse, just fix that, divided by the opposite. And the secant of the angle is defined to be the reciprocal of this, so it's the hypotenuse divided by the adjacent. And then finally the cotangent of the angle is the adjacent divided by the opposite. It's the reciprocal of tangent, okay? So these are the 6 trig functions of any angle, and notice all you need are these 3 quantities, right? The opposite, the adjacent, and the hypotenuse. And once you have those 3 things, then you form these ratios. Okay, so let's go ahead and make use of these in an example. Let's find the exact values of the 6 trig functions of the angle theta. Now, do you see where they gave the angle theta? It's right here. So what would the opposite be? Well, the opposite side. That would be this, right? 3 is the opposite because it's across from the angle. And the adjacent would then be 4. And of course, this right here, that's the hypotenuse because that is opposite of the 90-degree angle. So let's call that just h right now for hypotenuse. Now, if you want to find the values of the 6 trig functions, you need all 3, right? You need the adjacent, you need the opposite, and you need the hypotenuse. So how are we going to get that hypotenuse? Well, the good news is that when you have right triangle trigonometry, you can apply what's called the Pythagorean theorem. Pythagorean theorem. And it says that, well, a squared plus b squared is equal to c squared. Now in this equation, the c is the hypotenuse and the a and the b are the other sides of the right triangle. So here I see that, oh, the square of the hypotenuse, that is, this is my c, right? So h squared is equal to, well, the square of one of the legs, so 4 squared, plus the square of the other leg, 3 squared. So h squared is equal to 16 plus 9. So h squared is 25, and h therefore would be positive 5, because the length is positive, right? That's the length of the hypotenuse. Okay, so now that we have h, right, we have the hypotenuse, so let's write that up here. This is equal to 5. Now I'm ready to find the 6 trig functions of this angle theta. So let's see, sine of the angle. Well, sine is opposite 3 divided by the hypotenuse, which is 5. So sine would be 3/5. Cosine of the angle is adjacent. Oh, adjacent. So it's 4, and then divided by the hypotenuse, which is 5. So 4/5. And then tangent is defined to be opposite, 3, divided by the adjacent, which is 4. Okay, and then cosecant of the angle. Well, cosecant we know is the reciprocal of sine, so it's 5/3. And secant, well, yeah, we know it's the opposite. We know it's the reciprocal of cosine, but you could also say it's also hypotenuse divided by adjacent. So it's 5/4. And you could just check your work, and you see that it is indeed the reciprocal of cosine. And then finally, cotangent is the reciprocal of tangent, which is cotangent of the angle is 4/3. Okay, and this would be our answer. These are the values of the 6 trig functions. Notice that I never actually found the angle. I only found the trig values of the angle, the values of the 6 trig functions of the angle. Okay, let's try a problem similar to that now, still using the same definitions. Okay, so on this first one, let's first of all get rid of that. Okay, so what are we asked to do? We're given some information about this triangle, right? We're given the hypotenuse is of length 12, and we're given that this angle is 30 degrees, and we're asked to find x and y. When you have a problem like this, where you're given some information about the triangle, but you're asked to find either the other sides, or sometimes you're asked to find an angle, that's called solving the triangle. You'll see that in different textbooks. All we mean when we say solve the triangle, or when you're solving the triangle, all you're doing is you're finding the lengths of the sides, or the measure of the angles. Whoops, let's try that again. The measure is just how big the angles are. So of the angles. Okay, that's what we mean when we say oh, solve the triangle. So here they're asking us to find x and y, but in other textbooks they'll say, oh, solve the right triangle. Okay, well, what do we know? Now when I look at this, I see what information I'm given, right? Let's say I'm after x. Well, I have this angle and I have the hypotenuse. So in reference to this angle, can you think of one of the trig functions that involves the angle, the hypotenuse, and the x? So let me ask you, what's the relationship of the x to the angle? Would this be the opposite or the adjacent? This is the adjacent for the angle 30 degrees, right? So we have the angle and we have the hypotenuse, and we want the adjacent. So what trig function are we going to be interested in? We're going to be interested in cosine. So, and the reason is because cosine of 30 degrees is, by definition, the adjacent, which is x, divided by the hypotenuse, which is 12. Do you see that? So when you set up in a little equation like this, you're looking to have 2 out of the 3 known so that you can solve for the third unknown one, right? And I said, hey, I have my angle, I have the hypotenuse, and if I'm looking for the adjacent, cosine is the perfect trig function. So to solve this, I'm going to multiply both sides of this equation by 12. So let's do that. Multiply both sides by 12. And I'm going to get, well, here the 12s are going to cancel, right? So I've got x is equal to 12 times cosine of 30 degrees. And cosine of 30 degrees is equal to root 3 over 2. So this is equal to 12 multiplied by root 3 over 2. So my answer is x is equal to 6 times root 3. And I got that because 2 went into 12 6 times. So that's my value of x, 6 times root 3. Now let's try to find y. So we're going to apply the same logic, right? So in reference to this angle, what is y? Well, y is the opposite. And once again, you still know the hypotenuse. So what involves the angle, the opposite, and the hypotenuse? That's right, it's sine. So now sine of 30 degrees, right, would be the opposite, which is y, that is what we're looking for, divided by 12, which we were given, the length of the hypotenuse, right? So multiply both sides by 12, and you get, similarly, you get y is equal to 12 times sine of 30. And sine of 30, well, that's equal to 1/2. So it's 12 times 1/2. So y would be equal to 6. So there's the other part of my answer, right? So y is 6, and x is 6 times root 3. Okay, so these problems, it's all about thinking about the trig functions and the information that you're given. Let's try another one. Okay, here we're asked to find x and r. So when I look at this, I see x is down here and r is the hypotenuse, right? Now we don't know, you could call this h. In this problem they just label it, or I just label it as r, but it still represents the hypotenuse, right? So let's think about this for a second. Let's go for x first. So I have the angle, and I think about x. So x would be the opposite. So I have the opposite, but I also have the adjacent. So can you think of a trig function that involves the angle, the opposite, and the adjacent? Yep, that would be tangent. Tangent of 20 degrees, right? Tangent is defined to be the opposite divided by the adjacent. So tangent of 20 is x, the opposite, divided by the adjacent, which is 10. And if we multiply both sides by 10, we get x is equal to 10 multiplied by tangent of 20 degrees. Now tangent of 20 degrees is not something we're going to be able to do in our heads, so we can use a calculator to do that. And when we do that, let's see, x is about equal to, what's that going to be? About 3.64. I did that on my calculator. So I took tangent of 20 degrees, and then I multiplied it by 10, and I got about 3.64. This pair of squiggly lines means about, because this was an approximation to the second decimal place. Okay, now let's go for r. So once again, I look at my angle. I have the adjacent, right? And this is involving the hypotenuse. So I'm thinking of, once again, a function that involves the adjacent and the hypotenuse with the angle. And that, of course, is cosine. So cosine of 20 degrees, right, is the adjacent, which is 10, divided by the hypotenuse, which is r. And now this problem is a little different. We're looking for r, and r is in the denominator. But the same logic is going to apply. We're going to multiply both sides by r, because we want to clear the fraction. So r over 1, and then r here. So I get r cosine of 20 degrees is equal to, and the r's cancel, right? So r is no longer in the denominator, and I get 10. And now finally, let's divide both sides by cosine of 20. I'm trying to isolate that r. And the cosines of 20s, those cancel. So I get r is equal to 10 divided by cosine of 20 degrees. And if I do that on my calculator, I find that I get about equal to 10.64. Okay, so there's my value of x, and this would be my value of r. Now, if the problem actually said solve the triangle, I'd have it almost complete, right? I found my x, I found my r. All I'd have to do is give the value of this angle, the measure of this angle. Do you see what this angle would be? Well, if this is a 90-degree angle, which it is, these two angles have to be add to be 90 degrees as well, because all of the angles add to be 180, and that would make this value 70 degrees. All right. Okay, so now that we know how to work with the definitions of the trig functions in right triangle trigonometry, let's try an application. Okay, so we're looking for the height of a tree. So a person wants to find the height of a tree. If the person is 20 feet from the trunk of the tree, and the angle of elevation to the top of the tree is 75 degrees, how tall is the tree? Okay, first of all, there's a new phrase in here, and that new phrase is this: the angle of elevation. Now, let's define that. The angle of elevation. Angle of elevation. All we mean by that is if you were looking horizontally out into the horizon, let's say, and you saw something up like that, right there, that is the angle above the horizon. That's the angle of elevation. So it's the angle above the angle that it's the angle above what you get when you look to the horizon. So if you look to the horizon and then you look up, that's the angle of elevation. Likewise, we have something called the angle of depression. Angle of depression, and that's defined similarly. You look out into the horizon, and then if you're looking down on something, okay, the angle through which you're looking down, that's called the angle of depression. Okay, so in our problem, we're looking at we're 20 feet away from the trunk of a tree. Okay, let's first of all draw our little tree here. So here's our tree. Okay. And we're 20 feet. So let's put the ground here. Okay, and we are 20 feet, so maybe we're right here from the trunk of the tree. And we're looking up at the tree, and it's the angle of elevation, right? It's 75 degrees. So this would be the horizontal, and we're looking up. So let's draw in the angle of elevation to the top of the tree, way up there. So that angle, we're told, is 75 degrees, the angle of elevation. Now the tree forms a 90-degree angle with the ground, and we're asked to find, well, what else are we given? That we're 20 feet, this is us right here, right? We're 20 feet from the trunk of the tree, so this distance right here is 20 feet. And we want to find the height of the tree, right? So we want to find h. How tall is that tree? Okay, so what we're looking for is something that connects this angle to this side and that side. And you can see the triangle I've created, right? This is a right triangle. So what we're talking about in this section applies. Now, the height, what's that side in relationship to the angle? What would you call that? Wouldn't this be the opposite side relative to that angle? And wouldn't this be the adjacent side? This is the hypotenuse, I can tell, because it's opposite the 90-degree angle. So I'm thinking of something that involves the opposite and the adjacent for this angle. That would be tangent, right? Tangent of 75 degrees, that's equal to the opposite, which is h, divided by the adjacent, which is 20. Okay, and then I have 2 of the 3, so I can solve for h. I'm going to multiply both sides by 20. 20 over 1. And I get h is equal to 20 multiplied by tangent of 75 degrees. And when I do that on my calculator, I find that the height of the tree is about equal to 74.64 feet. Okay, and I gave the answer to 2 decimal places. Okay, so it's really important that you realize that the trig functions that we've given in this video only apply to right triangles, okay? So if you don't have a 90-degree angle, you can't use the trig functions given in this section. Okay, until next time.